Hi, fourth grade. Welcome back. We are going to be working on science. This is your science video for this week, one of them. There will be two. This week we're learning about motion. So I want you to get out your booklet that you got in your packet this week, the one that's titled Learning About Motion. Now, before we start reading, I want you to take a couple minutes, pause the video, and go ahead and do the before reading activity. Using the chart, I want you to fill in different thoughts or ideas that you might have about what motion is and how motion affects those around it, things around it, stuff like that. So go ahead and pause the video, take a couple minutes. When you're ready, come on back. I'm going to go ahead and get started on the reading. So we are looking at learning about motion. At the back of this book is a glossary with all the bold words that are throughout the text and the definition of what those words mean. Glossaries are important to help us remember what words mean. Learning about motion. And this is by Christina Denoy. We're turning the page and we are looking at the header, How Objects Move. And it has a picture of a giant swing like you might see at a fair or carnival. Starting with the header, How Objects Move. I want you to use your finger and follow along, read out loud with me so that you can practice your reading skills, okay? A child runs to catch the school bus. A leaf falls from a tree. These things are moving. Objects can move in many ways. Some objects move in straight lines. You may walk down the street in a straight line. If you drop a ball, it falls to the ground in a straight line. Some objects move in a curved path. People riding on a spinning carousel go around in circles. The moon's path around Earth is curved. Objects can also move back and forth. If you push a swing in the playground, it moves back and forth. There are many different ways to move. There are also many ways to observe and measure motion. Going over to the next page, starting with the paragraph. How can you tell if something is moving or standing still? You can compare objects to find out. Relative motion is the change in one object's position compared to another object's position. If you are in an airplane above a big city, you can see the buildings below you. They may seem to be moving, but you know that the buildings are not moving. You are. If you stand still and a dog runs past you, then the dog is the moving object because you are standing still and the dog is moving. Looking at the caption that goes with the picture, and remember, captions help us understand what's going on in the picture. So we're going to read the caption. Ready? The riders on this giant swing move in a curved path. And curved path just means circular. It goes round. We're going to flip to the next page. We are now at the heading, Knowing What is Moving. And it has a picture of a person on a bicycle. Reading the header first, then the paragraph, then we'll go to the caption. Knowing what is moving. By comparing objects, it is possible to figure out what moves and what does not. It also depends on your frame of reference or the objects you use to detect motion. Look at the cyclist above. To the cyclist, the bicycle he is riding does not seem to be moving because he's sitting on the bike. The bicycle is his frame of reference. But the people in the crowd that are not on the bike see both the cyclist and the bicycle moving. The caption up at the top. From the cyclist's point of view, the crowd is moving. From the crowd's point of view, the cyclist is moving. So remember, it's all about your frame of reference. Looking at the next side over here, we are going to be reading speed and velocity. Header, paragraphs, then caption. Speed and velocity. Speed and velocity are two measurements of motion. Speed is the rate at which an object changes position. You can find an object's average speed by dividing the distance the object moved by the total time spent moving. If a plane traveled 1,800 kilometers in 2 hours, then its average speed was 900 kilometers per hour. They took the 1,800 kilometers in 2 hours, divided it by 2, 1 for each hour, and got 900 kilometers for each hour. Next paragraph. Velocity is a measure of the speed and direction an object is moving. North, south, left, and right are some direction words. As an airplane takes off from the ground, it rises up into the sky. If it starts to move faster or make a turn, its acceleration changes. Acceleration is any change in the speed or direction of an object's motion. Acceleration can be speeding up or slowing down. We more often than not know acceleration as speeding up, but please remember that it also means it can be slowing down. Looking at the caption up at the top, it says, an airplane accelerates when it takes off. Its speed increases. We're going to turn to the next page and we're going to be looking at the header, force and motion. And it has some kids playing tug of war on the picture. Starting with the header, we're going to read both sides and then we're going to read the caption at the top. Force and motion. Force is a push or pull. Force can set in motion an object that is not moving. It can also make a moving object change direction, stop, slow down, or speed up. Some forces take effect on contact. That means these forces must touch an object to have an effect on it. They touch it and the object moves. Hitting a ball with a bat is a contact force. Contact means it touches. The bat must touch the ball to make the ball move. Other forces take effect from a distance. These forces do not have to touch an object to have an effect on it. The force of gravity on Earth pulls objects to Earth without touching them. Remember, gravity from our previous lesson holds us down to the ground. If you push or pull an object, you change its motion and position. How much of the motion and position change depends on the strength of the push or pull. The harder you hit a ball with a bat, the farther and faster the ball will fly. Looking at the next header at the top, combined forces. Forces can be combined in different ways. If you pull on a rope, the force of that pull will move the rope in your direction. If you play tug of war with friends and both pull sides on the rope with equal amounts of force, Both forces work against each other. The forces are combined but balanced. The rope does not move in either direction. Not all forces are balanced. Suppose more people are pulling on one side of the rope than the other. They will pull on the rope with more force than the people on the other side. The rope will move toward the side using more force. Looking at the caption up at the top, the rope is not moving because the combined forces on both sides of the rope are balanced. They have 2 students on each side that have the same amount of force that they're pulling on the rope, so they are balanced. Looking at the next page, we're going to start with the header, motion and force. And then we're going to read the story and the caption. Motion and force. This next word, some of us might know. This word is inertia. I want you reading along with me. Inertia is the resistance an object has to any change in its motion. Suppose you are riding in the bumper cars at an amusement park. What happens when you hit the brakes too fast or bump into another car? Your bumper car stops short, but your body continues to move forward. Your body has forward inertia, which keeps you moving after the car has stopped. The same thing happens if you trip while running. Your feet stop when they hit something, but the rest of your body continues moving in the direction it was going. You may even lose your balance or begin to fall forward. The body's resistance to the sudden stop is inertia. Resistance means it doesn't want to do it. It resists it. The more mass an object has, the more force is needed to change its direction. Looking at the caption at the top, even after the athlete releases the ball, her body continues to move forward. This is because of inertia. Next side is friction. We're going to start with the header. Friction. If you rub your hands together quickly, what happens? Your hands grow warm. This warmth is caused by friction, a force that acts when 2 surfaces rub together. Friction changes depending on the surfaces of the 2 objects in contact. Objects with smooth surfaces have less friction than objects with rough surfaces. Friction also changes depending on how hard the surfaces are pressed together. Just like when you try to make a fire with a stick and you're rubbing it with your hands, okay? It has friction. If you ride down a snowy hill on a sled, you can go very fast. What would happen if more weight were added to the sled? The friction would increase. By adding weight, more friction is created because the sled is pressing harder against the snow. Friction can also be decreased or lowered. Smoother surfaces have less friction. If you waxed the bottom of the sled, the friction would be reduced. The sled would move more easily. Looking at the caption up at the top, picture of the little girl on the sled. The surface of snow is very smooth, so it has little friction. This makes snow slippery, perfect for sledding. We are on the next page looking at the header, force, mass, and energy. Force, mass, and energy. Gravity is the force that pulls objects toward each other. The force of gravity between objects depends on their mass and their distance from each other. Objects with more mass have greater forces of gravity. If you throw a ball in the air, Earth pulls the ball back down. Why doesn't the ball pull Earth up? Earth has much more mass than the ball has. This means it has much stronger gravity than the ball. Gravity gets weaker over a distance. Gravity affects an object's weight. Mass is the amount of material in an object. Weight measures gravity's effect on an object's mass. The force of gravity can cause an object's weight to change. An object weighs more on Earth than it does on the moon because Earth's gravity is stronger. Unless mass is added to or removed from the object, its mass is the same. Looking at the caption at the bottom, if you throw a ball upward, gravity causes it to fall back down to Earth. Next side, we're going to read the header, how to measure force. One way to measure force is with a spring scale. Pause for a minute. We did talk about spring scales earlier in science. It is a measuring tool used in science. And there is a picture of it on this page that shows you what a spring scale looks like. Okay, moving forward. You can hang an object from the hook at the bottom of a spring scale. This causes the spring to stretch. The weight of the object determines how much the spring stretches. A heavier object has more force. A stronger force will stretch the spring more. So the heavier it is, the more it's going to pull that string down. Spring. The scale shows the measurement of the object's force. Force is measured in units called newtons. It takes the force of about 1 newton to lift a small apple. The newton was named after Sir Isaac Newton, a scientist who made important discoveries about both force and motion. And looking at the caption at the bottom, it says a spring scale is measuring the force of an apple. And what is it measured in again? If you said Newton, you're correct. I'm sorry, I apologize. Looking at the next page. We are now looking at the header that says motion and energy. Motion and energy. The ability to move something is known as work. Energy is required to do work. Kinetic energy is the energy of motion, and that's something we learned in our lesson last week. Hopefully everyone remembered it and kept it up here. Kinetic energy is the energy of motion, meaning movement. Everything that moves has kinetic energy. A tennis ball flying across a court looks much different from an airplane flying through the sky. What do they have in common? Both have kinetic energy because they're moving. The plane has more kinetic energy than the tennis ball has. Objects with greater mass and faster speeds have more kinetic energy. Objects with less mass and slower speeds have less kinetic energy. Looking at the caption, this tennis ball has kinetic energy because it is in motion. It is moving. Next side with the picture of the boy on the slide. We're going to read the paragraph, then the caption. What do a stretched out rubber band and a child at the top of a slide have in common? Both have potential energy. Potential energy is stored energy. And we talked about this also in our lessons last week. Remember, potential energy, just like all the potential stored inside of us, is stored inside of an object, which means the object is not moving. If it was moving, it would be kinetic energy. Continuing on. Even though the rubber band and the child are not yet moving, both are ready to do so. They can release their stored energy at any time. Once they move, their potential energy changes to kinetic energy. It is no longer stored. Why? Because they're now moving. Looking up at the top at the caption, at the top of the slide, the boy has potential energy because he is about to move. We are now looking at the page with the header that says changing energy. Changing energy. The amount of energy an object has cannot change. However, the kind of energy can change. Objects can switch back and forth from kinetic to potential energy. Think of moving back and forth on a swing. As you move upward on the swing, you have kinetic energy because you're moving up. At the top of the swing's path, your kinetic energy changes into potential energy. This is because you kind of pause when you're up at the height as far as you can swing. As you begin to move again on the swing, the potential energy from up here changes to kinetic energy as you begin moving again. Looking at the picture of the boy swinging, we're going to start on the left because we always read left to right. We're going to read the caption on the left, then the one in the middle, and then the one on the far right. While on the swing, the boy's energy is constantly changing. While in motion, the boy has kinetic energy. When the swing reaches its highest point, the boy has potential energy. On the next page, with the picture of the people on the corner and the building, we're going to read the paragraph, then the caption. Motion can be affected by forces acting upon it. Forces can act on an object from direct contact or from a distance. Friction and gravity can cause changes in an object's motion. Energy can be kinetic or potential depending on an object's movement and position. When motion changes, energy is always required. Look at the objects around you. Notice what is moving. Notice what is fixed in place. Do you know what is making the objects move? Motion and energy play a big part in everyday life. Without them, we wouldn't go anywhere. The last page of the packet has our glossary with all of our words in bold and the definitions of what they mean. And then it has an after reading set of questions. There's 4 quick little questions for you to read through. Answers can be found in the story that we just read. As always, you go back, reread, rewatch the video if you want to help you find the answers to these questions. Okay? I hope you guys are all staying safe and healthy. Miss O and I miss you guys so much, and we cannot wait till we get the chance to see you guys again. I will be back shortly with the second science video.